Hello everyone, I'm Dewei Wang. This is a lecture on chapter 14 of Spurrier and Taupe's textbook. The title of the chapter is The Role of the Business Analyst in Technical Design. It seems to me from the title like a chapter talking about the role and responsibility of business analyst, which is the main focus of training in a graduate level class in a business school. However, if you look into the content of the chapter, you will find that it's not talking about the role of the business analyst. Instead, this chapter introduces a lot of the details of UML modeling and how do you use the modeling and as a documentation effort and use modeling as a communication tool to talk to the technical personnel in the project team. In order to do that, you have to evolve yourself from your learning of conceptual modeling, which we have discussed earlier in the area of domain modeling, for example, or use case modeling, and into a field that we talked about design using UML. And using UML model to design a system require a lot of the detailed specification of your software requirements. And it is very important to still remember that any system based on its original architecture, you can divide the system into data, process, and interface. And whenever you are dealing with a model, try to think in that direction. What kind of model can represent which part of the system? Say, for example, the domain model in the conceptual level, in the analysis stage, can represent more on the data perspective of the system. The behavior will be bring in from the overlapping between the domain model, UML class diagram, with other more detail-oriented diagram, process-oriented diagram, like sequence diagram or activity diagram. So this process of going back and forth between a structure diagram such as class diagram to a more behavior diagram is the process of using UML model and modeling in general to achieve the purpose of the communication between a business analyst and a system analyst. And to become the bridge of business analyst and the system analyst between a end user to very technical programmer type of personnel. And it is very important for us to understand a lot of these technical oriented concept and terminology and the new development of the system development in today's world. And by the time you reach this particular chapter, I believe that you have already, from our assignment and the reading of the learning module, you have learned already something about the low-code and no-code development environment, such as Mendix or the Agile Point that we have used in the classic example. And you also learn something from other programming classes in terms of different development tools, programming language, and infrastructure environment, such as the cloud environment that we are encountering today. So going back to the original discussion of how we look at and conduct a very initial stage of the system analysis, we talk about the three different aspects, three different layers from the network architecture perspective. Three-tier architecture, presentation layer, interface, business logic layer, process, data access layer, data. And if you extend that a little bit more by dividing the data layer into data access layer and the database layer, then you have a little bit more in the fourth tier or even five tier if you put the internet into the structure. So again, this division or the classification of different layers and the functionality in some perspective you can describe a system is a good tool for us to organize and manage our concept in the process of development. So there will be models specifically suitable for different layer of the design. And in modern day business application development, before I would say 2010, we rely a lot on this data-oriented system development because business run on data. And a lot of these effort before 2010s are to organize and collect data in a structured format. So building a data model become the foundation for building or designing any information system. So your textbooks start from the data layer and then later on move to the business logic layer. And you also see there are arrowhead going between these layers in the diagram you see on this particular slide. It represents that there are overlapping concepts and there are aspects that need to influence each other layer. And how are we going to be doing that is actually the main job for us to understand in this particular chapter. So the data layer depends a lot on the foundational relational database model, and it used the term called logical view of the data model. Logical is somewhere between the concept called conceptual layer and the physical layer. Physical layer is actually the final database or database management system you can see in the operation environment. And logical is the meta level, that is the design. Now, if you have learned database course already, and logical layer usually are referring to the data definition language or SQL language layer, and you build database schema using this kind of model. And of course, modern day we have the so-called NoSQL database as well. But they are in a way can still be represented in a broadly speaking or actually broadly defined relational model. And most commonly seen model in relational model is of course the ER diagram. And ER diagram and combined with the class diagram, actually class diagram can be used to model ER diagram because class diagram has all the necessary vocabulary. Vocabulary means that the component that you can describe the entity, and in class diagram we call them entity class. And you have the attribute, and in class diagram we have attribute. But of course, class diagram have additional vocabulary that you can use to describe other aspects. That's how you link the data model to other behavior model. So in class diagram, there are components we describe as behavior or operation or function. Those function and operation behavior or message can be linked to our sequence diagram and other more dynamic type of UML diagram. And the typical ER diagram can be converted into something called the schema representation. And this schema representation is actually very close to the SQL language already. Now, in order to do a SQL language, you have to provide more detailed descriptions. Say, for example, each attribute need to be described in more detail in terms of the data type, in terms of the data range, in terms of the nullability of that particular column, and so on. But if you have taken the database classes, you will not be you'll be familiar with this type of representation. It's usually again called a schema representation. Without explaining too much, because you're going to be learning more of this in the database class, a schema representation usually describe the table you're going to be building in a database and the primary key and all the column that you require to build the table. And finally, you build a relationship among table using foreign key. And different organization and different standard use different convention to describe the foreign key and primary key. And typically use underline notation to represent a primary key, and sometimes use a iterate font style, or in this case we are using a dashed underline to represent the foreign key. It's very intuitive. I believe you can read this without any too much problem. And the ER diagram, or the more extended UML class diagram, usually describe the structure of all the relevant entities or users or parties that, or in UML terminology called actor, how they interact with each other in the virtual environment, how their representation interact with each other in the computer system. And this is actually the foundation definition of business rule. All these relationships you see in such a model actually represent the higher level view of how they interact with each other. Sometimes we give this relationship a name, then you will know they represent some sort of a business transaction in the operational environment. So in our assignment exercise, we will go through this process of building the entity and the relationship and how map with each other using cardinality. And when we convert them into UML diagram, the terminology change a little, but the basic concept will remain the same. Both the ER diagram and the class diagram in UML actually represent the same business structure and the same higher level relationship or business rule that you need to define in a more detailed process model. In other words, every time you see a line in between two entities or two classes, you are talking about there potentially other process that's going on between these entity. Say, for example, if we look at the entity between employee and sales, so you're talking about that employee will handle sales, and one employee can handle many sales. Their name will show up in many sales receipt or transaction or invoice. And how do you process the sale that become a behavior model? And to describe that little line, my cursor now moving here, you actually need to draw a flow chart or activity diagram or a sequence diagram to describe that. That is actually the basic linkage between a UML class diagram and other more behavior diagram. And a lot of this design effort we talked about in this chapter is actually going back and forth between a higher level structure class diagram to a more detailed level the sequence diagram or activity diagram to make sure they are consistent and meeting the requirement from the end user's perspective or from the functionality or other requirements perspective. And those are the process, very tedious and very lengthy. And in many methodology, we usually use a method called iteration. You probably learn in the Agile concept, in the Scrum. In every sprint, you try to kind of grind this out and make them consistent. And that is why we are talking about this iterative process, because you are in the process try to make them consistent between higher level structure and the lower level detail requirement, and a change, of course, in the needs of your business operation and process. And in database course, of course, you also learn there is a skill or actually a technique called normalization. This is a set of mathematical derived rule that used to make sure the data among data sets are consistent with one another. Make sure there is no anomaly in existing the data set. In other words, that to ensure the data quality is consistent. Say, for example, you might want to make sure a person's personal record in the database has the most recent phone number and will not record the phone number that the person used like 10 years ago. And that kind of a job actually can be achieved through the process of normalization. And this is also some of this grinding process we do in the system design. Try to make sure that your system is consistent. Now, even with a very tedious or a very laborious process, you might still encounter error. That is because business situations change all the time, and there are always unseen situation may show up. This ensures that the needs for the continuous effort for the business analyst and the system analyst to continuously improve the performance of a software application, and that is how we get our job actually. So be sure that you try to understand the process and know The effort of going through this tedious process is to make sure that you have the best data quality and make sure the transaction of your business can be conducted smoothly. Since you're going to be learning the normalization in the kind of introduction way in database class, in this particular class we will not go through too much about the normalization, and you can probably read a little bit about the normalization and understand the terminology, so you know there are first normal form, second normal form, third normal form, and fourth normal form, multi-value dependency, that sort of a thing, and some other. There are actually 7 different normal forms you can learn. And the result of the normalization is usually breaking up a more sort of an unnormalized table into multiple, more consistent set of table, linking with foreign keys and primary key relationship. Doing this can ensure that our data set is more consistent from one concept to another. And in different application, the data model requirements are different. In a normal operational situation system or operational database, we talk about normalization. But on the other hand, in today's environment, we have this strong need for data mining, artificial intelligence, and data warehousing, that building process. This leads to another concept of data organization. And this is one example called a star schema. It's actually in database we call them as a denormalized form of the database design. And this database structure is designed not for the purpose of conducting business transaction. So the relationship among them does not require or does not represent the business process anymore. It represents more about how do you search and summarize your data. So we have this star schema as another form of data structure. And again, depends on different needs of your system. You will have different type of data, metadata, or so-called logical data model to be used. So on the other hand, when we talk about the linkage between the data model or domain model to the behavior model, is not so obvious in a star schema type of representation. So most of the time when you go into the UML modeling course or UML world, you will be talking more about the operational level design instead of this data mining, data warehouse type of design. One interesting phenomena to pay attention to is today's world. We talk about this NoSQL environment, and the NoSQL environment move us back to the age that we have. We manage our data using file management system, as well as we have picture file, video file. We have Word document, all these file. So the relational database model is not sufficient to document all these so-called unstructured data type. And in recent environment, cloud big data environment, we still have the need to exchange data. And this evolved from the XML to today. We have data models such as a JSON model. This is called pronounced as JSON or JSON model, used for data exchange. And this JSON model is more or less an object model that can cover both the traditional relational model as well as more hierarchical type of data set. And this is, as you probably can see, that the JSON model is actually based on one very simple concept. That is that in our schema definition, we will carry both the attribute name as well as the value with the model. In the traditional relational model, they will separate this metadata with the value, but now we combine them together. This will be enable us to carry out the transfer of data from one system to another, because the receiving system, they can read both the definition of the data as well as the value of the data. The drawback is that the performance will be slower because every data set you have to send both the metadata and actually every record or every row of the data need to be defined in this format. But with today's evolving speed of communication and the processing power, this becomes less and less a problem. It is still a problem when you go into the big data world because we're talking about that you are doubling the size of every data record, and if your data set is really big, it will still double the time for you to process the data. So with the discussion of this non-traditional data schema and data model, we kind of conclude in this particular stage about data model and move into more process or functional model in the next slide. The default tool in UML to document the process is the sequence diagram. It's not the activity diagram that we, as a business analyst, is more accustomed to use. Activity diagram is can be seen as a replacement of a flow chart in UML environment, but a sequence diagram is more precise and more detailed in the way that the sequence diagram can actually provide the definition of your function and process in the model. So this will give the programmer more, you can say, directions or constraint of how they going to be writing their computer software. And as a matter of fact, the UML diagram over time, even though there are like 9 different diagrams, standard diagram in UML, the most popular diagram, the number 1 is the class diagram. The number 2 is the sequence diagram. It's not activity diagram. People are still using flowchart to document the business process. But when it is time to document the software detail and especially the definition of the functionality, sequence diagram is the go-to option for most of the programmer. Now, sequence diagram was its name because it documents the best of a process logic in terms of sequence. Not so much about repetitions and decision making, that sort of a logic, but sequence. Because the basic structure of any programming language is the sequence of the process you have to go through step by step to complete a particular task. That is the foundation of any algorithm. And so sequence diagram is assuming something what we call the sunny day process, from the top as the first step to the bottom going through the process. And this involves the object-oriented concept of how objects collaborate with each other by request some of the job from one another to complete that task. And these requests will be the functional requirement. Say, for example, the actor, a user maybe, try to search for a customer name. So the system is being requested to do something, and the system have to be response with a responsibility of finding customer. So the programmer have to write this find customer program in order to complete the job. So every time you are asking the system or asking one component or one module of the system to do a certain thing, there will be a request. And this is also called request and responsibility. And in the older system design method, we call them CRC, collaboration responsibility model. So that's sort of a method we are using. So this is actually a perfect representation of the collaboration responsibility in a sequence diagram. And there are, in some situations, there will be also response or so-called return message represented by the dashed line. And this diagram is not a typical UML diagram. It has a response from every request. But actually, after UML 2.0, the response is assumed. So if you are having the regular called a call response, then we will not have the response showing up as a dashed line. Only an asynchronous type of response will require the dashed response. So again, this in here, we just look at a sequence diagram. Each one of this vertical line or object represents called the lifeline for a particular object. And we are looking at a program at the instant level. It's not at the class level, instant level representation in the UML model. And earlier I mentioned that it is a good document or a good diagram used to document the sequence, but it is not good enough to document repetitions or conditions. But again, you can still represent them using the notation in UML. It just does not is not very intuitive, not as intuitive as your diamond-shaped decision making in the flowchart or activity diagram. And for a business analyst, the first thing we do in learning sequence diagram is to build this thing called a system sequence diagram. This type of diagram treat the system as a black box. So we do not need to worry about what kind of software component or application try to interact with each other to complete the task. So we don't need to worry about, say, how the database system working with our application server to complete a job. We treat the system as a black box, and the diagram you draw in here is called a system sequence diagram. Now, in the traditional system analysis and design, we usually call this type of diagram as context diagram. So context diagram is a diagram that we do not need to worry about the detailed implementation of the system, but just only think about the input and output. So all the line that you see in between in the system sequence diagram are actually input and output from the system. So as in this case, the example is a cashier. So what kind of information the cashier need to provide and what kind of requests the cashier need to ask from the system, and what kind of output the cashier expect out of the system is represented very well from this particular diagram. And this diagram is particularly important for business analysts because it ties directly to the requirements that you try to collect from the user. So these outputs are the required result that you're looking at from the system. And the message going in, the line going to the right, the solid arrow line, actually represent the function or the functional requirement that you ask the system to perform. And those become the responsibility of the system you're asking for. And the system diagram represent again by the many different components. You can also see there are additional components used to represent different type of situation. An object can be created in between of the process or destroyed and throw away. So say for example, you can create a record and delete a record. That's represented by this lifeline that exists not at the beginning on the top, but in the middle, and any lifeline or any program can be terminated and you use a cross at the end to represent it. So once you consider all the responsibility and requirement, and you can break them down into the collaboration mechanism in between different program module, and this complete our design sequence diagram. Now in our assignment, you will have an opportunity to kind of take a look at how this is done and how they link to the other. One of the interesting point to notice that is that these line, this message that we call the message, are actually represent as the behavior of your class diagram. So each one of this line need to be represented by a behavior in your class diagram. So if you identify something from the sequence diagram, you have to map to the class diagram to see which one of this class is responsible to perform this job. And so this become how the programmer need to write each individual classes and their corresponding function. And the so-called programming logic, so where is the programming logic in class diagram? It's in the definition of the function. Each one of this function require an activity diagram or flowchart, or more precisely, sequence diagram to describe how this program needs to be written. So in a way that you can say the sequence diagram is more or less like a in a programming world we call them pseudocode. It's actually a representation of the logic, but not the exact programming language you are writing. So mapping to the methodology, the iteration in the design stage of the system development is to try to make sure that you are consistent between the class diagram design and your sequence diagram design, because we have to analyze the detailed process of the programming logic, and these logic need to be represented in your class diagram as a definition of the function. And that process is again iterative, going back and forth. So that's why we have this cycle iteration concept in our agile methodology. And finally, the most of the the transaction processing system we are looking at is a very standard design already, because when you are conducting business, you buy and sell. That's been going on for so many years and has been processed by computer for more than half a century. So that is usually documented in some of the predefined design, and these are the design, we call them as design pattern. And your textbook introduce you with a few example of the design pattern: MVC, MVP, MEVP, and the Gano 4 pattern, and so on and so forth. Some of them are more detailed at the very programming language level. Some of them are more higher level at the business process level. The MVC, MVP patterns are at the business process level. And the MVC, MVP, and the MVVP model represent different concepts of how you design a system, how a user interact with your system. And if you map this model, controllers, and view into data, process, and interface, you can see that the user can actually interact with the system in a different interaction method. The detail of how to implement this method will not be discussed in our class, but basically it's representing a higher level interaction process, can be represented in UML called a package diagram. And the package diagram is actually a very similar to class diagram. It's just the scale of the diagram is much higher. You put a lot of class diagram into one package to represent a software component, and that component can be looked at in a more architecture view, higher level, meta level view, and that creates this type of pattern. And when you map this higher level, this pattern into the system design, it becomes the representation of how you map the architecture, different layer. If you learn in the network communication class or in the database class, you learn this different layer, how each layer talk to each other to complete a job, and become that typical pattern that we are looking at in most of the business operation. And over time, there evolved many different, you can say, principles or patterns that used to guide our design effort. And GRS, ASP, or GRASP is one very classic example. It has some principle, including low coupling, high cohesion, information expert, controller, and so on and so forth. Let me try to use the minimal time try to explain this concept. And if you look at something that we have encountered in real life more often, says iPhone, right? So iPhone is a computer information system. It has all this layer we have talking about inside the iPhone. So you have data. So you need to have some sort of a memory that you can build into the iPhone, and you have a processor. Processor in terms of the CPU that you use in the iPhone, and you also have the communication or interface layer, the user interface, the touch screen, the what do you call this, retina recognition features, and your fingerprint function, that sort of interface and also that you have this network communication, the mobile network you have to communicate to. These are the interface layer. So basically, when you look at an iPhone, it is a device, something what we call is high cohesion. And the high cohesion means that the iPhone itself is more like a unit you will not actually break in the past. I don't know anyone if you remember. Back to 20 years ago, before the first iPhone was invented, and most of the cell phone require a battery. So there will be a business of buying battery because battery was not as good as today. So you can easily see the battery, and you can change the memory chip for the cell phone. It's very modularized. But today we have this iPhone that is more like a one block. And this one block, the concept of you put everything together in their logical unit is called high cohesion. And how you interact this module with another is called the low coupling. So the iPhone is a typical design of the inside iPhone is a high cohesion the design, and outside iPhone you have a low coupling because we only need the mobile network and the touch screen to interact with the outside world. If you have an iPhone that is very quickly run out of battery, say for example you have to plug in a battery or a backup battery all the time, that will not be low coupling because you always have a wire connecting to the iPhone. So those are the concepts that we have in design. Actually, a lot of them are very intuitive. Well, but basically, if you look at the difference between iPhone and the Android phone is more modularized, and they have their concept of high cohesion and low coupling are different, and because they have tried to divide the component in a different way. And finally, at the lower level of the design pattern, this was actually the term design pattern was first introduced in the computer science called the GAN of 4 pattern. And they design a lot of this programming pattern. And for those of you who are interested in involving more technical computer science of the training, or if you are coming from the computer science training, you will learn more about the lower level pattern like singleton pattern, strategy pattern, observer pattern, management pattern, state pattern, and so on and so forth. At the philosophical level, these can be scaled up at the business operation and business design. But for the purpose of our class here, we will not go into too much detail about design pattern, but just familiar yourself with these terminology will be good enough. And that will be the summary of chapter 14.